What if the biggest mystery in the universe isn't made of missing particles, but trillions of tiny, invisible primordial black holes? These aren't the remnants of dead stars. They were born before stars, before atoms, in the very first second of the Big Bang. To understand this wild theory proposed by Stephen Hawking, we have to go all the way back to the beginning. We've looked into the eye of a black hole once again. Once again, we found a way to observe one of the most extraordinary and terrifying things in the universe. But this time, what we saw felt even more exciting. Because this time, we looked at ourselves, at Sagittarius A star, the foundation of our own home. As far as we know, it's one of those supermassive black holes sitting at the center of every galaxy. We're still not entirely sure if it exists because our galaxy formed, or if galaxies exist because of it. But one thing is absolutely certain now. Yes, there is a black hole right there. Case closed. I'm so happy about this topic, and we followed it with much more interest than I expected. We want to get away from everything so badly that it felt like a cosmic miracle, and we dove into the details. Thanks to this intense interest, I'm guessing you have a general idea of how we captured this image. In short, it was thanks to the Event Horizon Telescope collaboration, which turned our Earth into one giant telescope. The Event Horizon Telescope? It's such a great name, isn't it? But, putting all those details aside, I just want to talk about black holes, to explore the theories and try to understand. And there's one possibility that occasionally catches me off guard. I think about it a lot, and it gets me excited. It's a crazy idea. Really crazy. But just in case it sounds too crazy and you want to ignore it, let me warn you up front. The father of this idea is not someone you can easily ignore. I'm talking about Stephen Hawking and his primordial black holes. Do you know why these primordial black holes are such a wild concept? Here's why. When we ask how a black hole forms, you immediately put a star in the equation. We talk about its birth, its death, its collapse, and the Schwarzschild radius. We say they are the remains of dead stars. Well, these are entirely different. Because when these hypothetical primordial black holes formed, there were no stars yet. Forget stars. There weren't even atoms. There was no matter. Nothing at all. It's thought they were born right at the very beginning, when even the laws of physics as we know them didn't exist. We're talking about black holes forming inside that incredibly hot, searing soup of early plasma made only of quarks and gluons. Meaning, they could literally be black holes produced by the Big Bang itself. So basically, before there was any matter to collapse, the sheer crushing density of the Big Bang itself might have squeezed pockets of pure energy directly into tiny black holes. And what's even more interesting, since finding normal stellar black holes is already so hard, if these primordial ones exist in massive numbers, do you know what they could explain? One of our biggest mysteries, dark matter. It's a crazy idea and just as exciting. But let's go back to the origins of this wild idea. The 1970s. Stephen Hawking and Bernard Carr. Hawking was obsessed with the early universe, spending a huge part of his life taking mental journeys to that era. During a thought experiment with his friend Carr, they visualized the very first second right after the Big Bang. An incredibly dense environment. But some parts of it, they said, must have been denser than others. Some specific points, who knows how many, might have collapsed into black holes within that very first second. But, like we said, these aren't the black holes we're used to. If this actually happened, there could be black holes smaller than asteroids wandering everywhere across the universe. Hawking immediately ran the numbers and came to this conclusion. Mysterious black holes could be literally everywhere. But after that, naturally, the idea just remained an idea. Except for a few names, no one really thought much about it. But in the 90s, they'd make a bit more progress. Because cosmic inflation, the theory of sudden expansion during the Big Bang, was starting to be accepted. This expansion, which ignored all known laws, actually supported the density imbalances needed to explain primordial black holes. I've actually made a video before about that very first second of the universe, right after the Big Bang. If you watch it, you'll realize that 1 second isn't a second as we know it. It's a second entirely outside your perception of time. You can think of that single second as an entire era. So, after the very first period of that 1 second era ended, and the incredibly hot plasma filling the universe cooled down just a bit, the quarks within that plasma finally found a space to combine. This combining process started to form heavier particles, and the sudden drop in pressure during this could have triggered a new black hole formation. But of course, in the 90s, no one understood the physics of a fluid made of quarks and gluons. Because of that, no one could guess how massive these primordial black holes might be, or how many existed. But today, we can estimate this environment much better and even calculate the pressure and density differences in that quark-gluon plasma. After years of hard work, we now regularly see papers about these primordial black holes in scientific journals. But what really made this topic popular again was that groundbreaking gravitational wave discovery made by LIGO in 2016. With this discovery, we gained a new sense and started to literally hear merging black holes. Since then, LIGO and similar projects have discovered many black holes, along with some truly confusing and incomprehensible signals. Even though it's not entirely clear yet, we're trying to estimate a black hole population. But according to some, this number might go way beyond your wildest estimates. Meaning, Stephen Hawking's crazy idea might just have come back to life. So basically, thanks to new tools like LIGO, we're hearing the cosmos in a new way, and it's whispering that Hawking might have been right. But let's get back to the part about dark matter. Dark matter is, as the name suggests, dark. We know absolutely nothing about it. Through numerous calculations, we know it's out there, we know it holds galaxies together. But we don't know what it is or what it's made of. There are many theories, like the possibility of unseen particles, but no, we have absolutely nothing in our hands. In one of the studies exploring this, a researcher named Karsten Jedamzik claims that these primordial black holes exist, are incredibly numerous, and are even responsible for dark matter itself. He published this study in September 2020, and he said this: there could be clusters of black holes crowded enough to fill the space between our Sun and Alpha Centauri.
You can think of these clusters as systems, with a central black hole surrounded by smaller ones.
Collisions between black holes in this system are totally possible, but the smaller ones crashing might not create gravitational waves big enough for LIGO to catch. As for the massive black hole mergers, LIGO is already catching those at a certain rate. The interesting part is, Jedamzik published a second paper and calculated a rate for these large black hole mergers. And when compared to what LIGO was actually catching, he saw the ratio was incredibly close. So yes, just like another astrophysicist pointed out, Jedamzik was presenting a genuinely logical argument. So what's the problem? The problem, of course, is a lack of observation. We're dealing with a multi-layered observation issue here. First off, we need to actually observe the primordial black holes Stephen Hawking predicted. We know there are black holes without accretion disks. And we know they can be caught using a technique called microlensing. If there are as many of these black holes as predicted, we have to catch them with this technique. And for that, we might have to wait for the Nancy Grace Roman telescope, which NASA launched, scanning the sky with this technique for the next decade. By the way, the person who had this microlensing scanning equipment added to the Roman telescope is Gunther Hasinger, the science director of the European Space Agency. He also believes primordial black holes could explain a lot of mysteries, but only if we don't solve it first with another discovery. That other discovery is, of course, finding the particles thought to make up dark matter. If that particle is discovered, maybe primordial black holes don't exist after all. And the idea that they are what we call dark matter could vanish entirely. So yes, we have an equation with several unknowns on our hands. But some crazy scientists are trying to solve these mysteries with every tool available. I'm telling you, we live in a fantastic time. In our short lifespans, we witness developments almost every year that used to take centuries. It's become a habit, and it feels like we're losing our sense of surprise and wonder. And that makes me a little sad. You know how people can't grasp what's happening when they're right in the middle of it? Imagine if we could go back and tell the people living alongside Galileo just how important he was. Or the people living in the same era as Leonardo da Vinci. Or during the Industrial Revolution, how many people were actually aware of it? I just want us to be aware, to be deeply aware, to get involved, and maybe even be the visionary people making some of these discoveries. Let's see what time will show us. There is so much more to discover, but as always, until we meet again, I'm so glad you're here. Much love.